There you go. That was for Flip. Okay, that's very important. Is that a peen? Every time I see ASCII art, I just assume it's a peen. It's not a peen, but you could imagine it could be. You know what I mean? Anyways, scaling up the Prime Video audio-video monitoring service and reducing costs by 90%. The move from distributed microservices architecture to a monolith application help achieve higher scale, resilience, and reduced costs. Type 1 in the chat if anyone here is surprised by this. Okay, there's some ones. Not a lot of ones. Not a huge amount. Okay. At Prime Video, by the way, I should probably bleep that out since, I don't know if you guys know this, but I work at Netflix, so I should probably bleep that out, you know what I mean? At Prime Video, we offer thousands of live streams to our customers to ensure that customers seamlessly receive content. Prime Video set up a tool to monitor every stream viewed by customers. That sounds just like Amazon, probably goes through Ring Doorbell. This tool allows us to automatically identify perceptual quality issues, for example, block corruption, or audio video sync problems, and trigger a process to fix them. That's kind of interesting. I wonder how they do some of these things. I wonder why they have a service to monitor it. I mean, it feels like Amazon should have heard of like Kafka and Atlas by now. Is that like a thing? Do they know about Atlas? Do they know about Kafka? Like you just set up an alert on Atlas, and just walk away, Our video quality analysis team at Prime Video already owned a tool for audio-video quality inspection, but we never intended nor designed it to run at high scale. Our target was to monitor thousands of concurrent streams and grow that number over time. That sounds like what happened. It sounds like a goal achieved. While onboarding more streams to the service, we noticed that running the infrastructure at high scale was very expensive. We also noticed scaling bottlenecks that prevented us from monitoring thousands of streams. So we took a step back and revisited the architecture and existing service, focused on the cost and scaling bottlenecks. I really hope this involves Rust. The initial version of our service consisted of distributed components that were orchestrated by AWS step functions. The two most expensive operations in terms of cost were the orchestration workflows when data passed between distributed components. To address this, we moved all the components into a single process to keep data transfer within process memory, which also simplified orchestration logic. Because we compiled all the operations into a single process, we could rely on this one. Is this like a story about how not to use Amazon by Amazon? It just seems really strange to me. Okay, I'm just going to be real with you. This seems really strange to me because in my head, if you wanted to solve this, you'd have a client that periodically uploads or updates and sends a message up to a server that has like bitrate or time-weighted bitrate or any of these magical kind of things you want to give to the server, along with like what video ID you're watching and some basic other items, right? And you take that little nice little item and you just throw that through a queue and make it into some big data portal, whatever that big data portal is. Hive, I prefer Atlas for real-time monitoring, blah, 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 blah. You set all that crap up, right? And then the next thing you know, you can just react to any show going wrong. Now, if they're monitoring individual persons, like it kind of almost looks like they're trying to say they're identifying individual perception problems and trying to fix that on an individual content basis, which seems a little bit or on individual stream basis. That seems a little bit weird. That seems like you're trying to make a client-side decision probably but on the server. Like if you had an AV sync issue and you wanted to fix it, you would just fix it on the client. Seems like. I don't know. Distributed systems overhead. Our service consists of three major components. The media converter converts input audio and video streams to frames or decrypted audio buffers that are sent to decoders. Defect detectors execute algorithms that analyze frames and audio buffers in real time, looking for defects. What? You're looking at all the video? What? What? Who does that? They must have like 10,000 customers and send real-time notifications whenever a defect is found. For more information on this topic, how Prime Video uses machine learning to ensure video quality article. Apparently not Netflix. Thank you for sharing company secrets. So I'm just thinking this is kind of crazy to try to process. Does that mean they're double streaming always? Is that what I'm hearing right now? Is that what I'm hearing? Effectively, the stream goes to two places. You know, the client could just tell you this. You don't need machine learning to tell you. The client goes, "Hey, buddy, that stream you gave me right there is all like low quality and a bit up. Okay, could you take care of that for me?" We designed our initial solution as a distributed system using serverless components. Serverless! Oh my goodness, everyone loves serverless. For example, AWS step functions or AWS Lambda. I try to say it with the most like intense robot sound, which was a good choice for building services quickly. In theory, this would allow us to scale each service component independently. However, the way we use the components caused us to hit a hard scaling limit around 5% of the expected load. Also, the overall cost of all the building blocks was too high. Serverless. I love it. Parallel execution, detector one, Wait, hold on. No, don't tell me. Are they actually taking a stream of video and then processing the video more than once? Like, each one of the videos are processed by different compute units with different detector algorithms? You know, Amazon's front end is in JavaScript. You know, you could just put a streaming algorithm in JavaScript. You know that, right? You know, you can update it. You can test it. If you pay me $3 million a year right now, I'll come over to Amazon. Make it 4, actually. Make it 4. Make it 4. Make it 4. Could help you out. Netflix, we do a lot of sweet things. The main scaling bottleneck of the architecture was the orchestration management that was implemented using AWS step functions. Our service performed multiple state transitions for every second of the stream, so we quickly reached account limits. The second cause problem we discovered was about the way we were passing video frames, images around to different components. Please tell me they decode it and actually look at images. Please tell me. Please tell me they're actually transferring images. They're not just doing like P and N and B frames. They're actually, because so like to do a B frame, you have to have the state of the stream in here. So if they're passing around just images to look at stuff, they might actually be decoding it and then passing raw dog and images around. This would be so great. Please tell me this is true. To reduce computationally expensive video conversion jobs, we built a microservice that splits video into frames and temporarily uploads an image. Just to monitor a service, dude, your client knows the bit rate. Oh my goodness, and televisions tell you like if they're getting completely effed off. Oh my goodness, what is this world we live in? Oh. The defect detectors where each of them also runs a separate microservice and then downloads images and processes it. However, the high number of tier 1 calls to the S3. But speaking of tier 1s, anyone have a tier 1 sub for me? Anybody? Little tier 1 sub? Little tier 1 sub? Yeah, is this a joke? This feels like how you would build... This honestly feels like modern JavaScript. This is like modern JavaScript in my head. To address the bottlenecks, we initially considered fixing problems separately due to reduce cost and increase scaling capabilities. We experimented and took a bold decision. We decided to re-architect our infrastructure. Please say Rust. Say Rust. $5 a month! We realized that distributed approach wasn't bringing a lot of benefits to our specific use case. So here's the problem, is this isn't a distributed approach. The problem is that the approach is wrong, right? Like there could be a distributed approach that makes a lot more sense, but this is just crazy, right? Can we all agree that this is just crazy version of distributed approach? You're literally taking a stream of video, which has been optimized to run through like a 90 hertz decoder to render onto like a 60 hertz renderer, and then you're actually taking this and you're double piping it. When you decode each frame, you're uploading it to S3. Then you have separate jobs that read from S3 each image to determine the quality of it. Like, that's crazy talk. Like, how are you... Just to know if the client is having a good or bad experience, you know the bit rate. Like, you know how many stalls are happening. Like, you know things because you download the video. Like, you know up here. You know. Why? Okay, anyways, conceptually, the high... Oh, hold on, I must have missed something. We realized that the distributed approach wasn't bringing a lot of benefits, really. So we packed all the components into a single process. That eliminated the need for S3 buckets. Yup, as an intermediate storage for video frames because our data transfer now happened in memory. Data transfer in memory. Super efficient. We also implemented orchestration that controls components within a single instance. The following diagram shows the architect of the decision after migrating to a monolith. I genuinely just think that they're just doing the wrong thing overall. Like, I'm happy that they're discovering that when you do serverless, like a lot of serverless, it goes crazy. I mean, it's kind of funny that Amazon's now discovering just a lot of serverless goes crazy, goes burr. But whatever. I can't even think about this. Conceptually, the high-level architecture remains the same. We have exactly the same components we had at the initial design, media conversion detectors and orchestration. This allowed us to reuse a lot of code and quickly migrate to a new architecture. The initial design, we could scale several detectors horizontally, and each of them ran as a separate microservice. Oh, no. So adding a new detector required a new... That means they're really splitting these streams. How many video streams are going through this system? How many are actually going through the system? Does that mean when you stream once on AWS, you're literally like 7 streams? It's your stream plus each detector? Whoo! I think I might have to buy puts against Amazon. Our team regularly adds more detectors to the service, and we already exceed the capacity of a single instance. To overcome this problem, we cloned the service multiple times, parameterize each copy with a different subset of detectors. We also implemented a lightweight orchestration layer to distribute customer requests. The following diagram shows our solution for deployment detectors when the capacity of a single instance exceeds. They still have a bucket. That means they're still like the analyzing results is still ran from a bucket. I know. There must, I mean, dude, real talk. Atlas. Atlas real-time metrics. There we go. Atlas real-time metrics. Like, oh my goodness, why are you giving me Mongo? Oh my goodness, is Mongo trying to, oh, Mongo has an Atlas now? Oh my goodness, Mongo, don't use Atlas. That's not for you. All right, whatever. I'm not even going to look at it. Mongo is now taking over the word and it's impossible to find. All right, let's keep on going. We'll look at it later. All right, let's see. Microservice and serverless components are tools that do work at high scale. Are they, Amazon? Sounds like you were failing at like 10,000, but whether to use them over a monolith has to be made on a case-by-case basis. Moving our service to a monolith reduced our infrastructure costs by over 90% and increased our scaling capabilities. Today, we're able to handle thousands of streams, and we still have the capacity to scale the service even further. Thousands? Yeah. So there you go. There's Atlas. There's the Atlas one here. I'll pull it up for just a second. Yeah, we do a lot of Atlas. Atlas is great. Atlas, like, the fun little story. So Atlas is like just effectively a real-time counter engager. That's all it is. And then you can overlay it with week over week. And then on top of that, you can take it, and when there's a high enough difference between week over week and your new value, you can actually cause alerts to go out. It's like a super cool tool. And what I did is that at Netflix, when we are expanding internationally and we are developing all of our originals, because I started before we had House of Cards, right? So we get House of Cards. That was great, but that involved all of our own assets. And then we get another original, and then another original, and then all of a sudden we have 20 originals. And then the next year was like going from 20 to 400. And we had no way to know, are the images actually there in production in the 15 different languages we supported, or whatever all the different things are, right? So it's like very, very intense. And so what I did is I took every single image and created an Atlas metric by a couple different things. And if it was missing from the back end, I would log it as missing through Atlas. And so we could tell at any point what video anywhere was missing images. And so that was like a huge nice thing. Sorry if there's ads. That's Twitch. Twitch has ads. Twitch ads, everybody. But yeah, so it was super cool. It solved all of our image problems by using Atlas alerting and a couple simple metrics, right? Like, not even hard. You know what I mean? It's pretty exciting. All right, let's keep on going. Some decisions we've taken are not obvious, but they resulted in significant improvements, such as streaming all the videos. We can handle thousands. Okay, cool. Thousands of streams. All right. Neat. I wonder if Netflix crosses the billions of streams at this point. You're going to have to 10x your 10x to 10x your 10x to 10x the 10x to get up to Netflix. So I hope you're ready for that scaling. Whereas running media conversion once and caching its outcome might be considered to be a cheaper option, we have found this not to be a cost-effective approach. The changes we've made allow Prime Video to monitor all streams viewed by our customers. Okay, hold on. I swear, am I just hearing this here? Amazon has thousands of concurrent streams. Old Man Judo, you missed the beginning, where they literally process every single request, every single video. Okay, get this, Judo. They take the video that the customer receives, pipes it to their backend decodes it, uploads the images to S3 as cache, and then other service reads these out to test the quality of said image and looks for detector problems. That is what they mean by cached and scaling and efficiency. Okay? And what I'm reading literally right now is Amazon Prime has thousands of concurrent streams. That literally means right now, I could very well be like half of Amazon Prime right now. I am half of Amazon Prime! All right, well, hey. This was just sad to read. But I love that they're improving engineering. I always love to see better performance, so good job them. But I think you could take a different solution altogether to make this a lot better. The name is the Streamagen. I work at Netflix, by the way. Did you know that?